webcast is now starting. All attendees are in listen-only mode.
Hi everyone, and welcome to today's AEE member webinar. Just a few housekeeping things before we get started today. My name is Sharon Hewson, and many of you have logged into these before, so welcome back. If not, welcome for the first time. And just a few things you need to be aware of. You will all receive a follow-up email in the coming days just thanking you for your attendance, including a certificate of attendance and a link to the recording of today's webinar. So if you have questions for today's presenter, Miss Cindy Renier, please post those in the questions section on your control panel. You'll notice that you have both a questions and a chat section. So anything that you need to direct to our presenter, please post in the questions section. Anything that you may have for me on the technical side, any support you might need on my end, please post those in the chat. And we will address questions as appropriate throughout the presentation. Ms. Renier will pause if possible at certain moments, or if it's not appropriate to stop, we will address them at the end. So please stay tuned so we can try and get all of those answered for you. Ms. Renier has shared her presentation with us, and if you look under the handouts section on your control panel, you will see it says there's one handout in there. You can go ahead and download a copy of the presentation from there. There's a PDF copy available to all of you. So without further ado, I am going to go ahead and introduce Ms. Renier. So Ms. Cindy Renier is technical leader for the commercial building systems at, sorry, excuse me, I'm moving my notes here. She is the technical leader for commercial building systems at Lawrence Berkeley National Laboratory and the executive manager for FlexLab. So FlexLab is DOE's building technologies testbed dedicated to integrated and low energy building and grid systems integration research and development. Cindy also manages several other research projects on integrated systems, Zini, and low energy whole building solutions. Prior to joining Lawrence Berkeley National Laboratory in 2009, Cindy designed low-energy projects including net zero carbon and LEED platinum facilities. So I will be passing you over in just a second to Ms. Cindy Renier for a presentation on cost-effective Zini scalable solutions from small commercial buildings. So welcome, Ms. Renier, and I am passing control over to you.
Great. Just let me get into presentation mode here. Thank you, Sharon. Really appreciate that great introduction. Again, my name is Cindy Renier. I'll be talking to you about this California Energy Commission sponsored project. Also on the call today is my colleague on the project, John Brushy, who's an associate principal at Integral Group. They were key contributors to this research project as well. I'll also be touching on a demonstration pilot project of this work that's being done through the city of Berkeley. So they're another project partner to be aware of. So without further ado, we'll just keep moving along. So first of all, stepping back, what the premise for this project is basically we recognize that small commercial buildings in the US have some kind of unique technical barriers to deploying deep energy saving strategies. And they really come across because of their scale. Because they're smaller, they generally can't afford to hire the deeper expertise of firms like the Integral Group or other consulting engineering firms. And so they don't generally have access to comprehensive cost evaluative information about what specifically for their building would make sense for retrofit. So generally speaking, they are relatively underserved in our market, and it's a relatively high transaction cost for them to be able to understand what energy saving strategies make best sense for them. So with this particular project, we had a couple goals. At a high level, we wanted to be able to develop whole building retrofit packages of technologies that enabled some typical small commercial office spaces to achieve zero net energy ready efficiency. And what I mean by that is that we want to be able to retrofit these buildings to the point where their annual energy consumption on a kilowatt hour basis would be offset by the use of renewable energy production through photovoltaic panels just mounted on the roof of that building. So there wasn't meant to be any kind of offsite generation built into the equation here. This is a California Energy Commission sponsored project, so the focus was definitely California, but a lot of the lessons that we learned in this project I think can apply to other climates in the US. And certainly the tool that we developed has some strong capabilities that extend to other US climates as well. So we started focusing on two distinct California climates, a Southern California climate and a Northern California one. And I'll describe the process in detail in a little bit, but essentially we were developing packages of cost-effective technologies that would work for small commercial buildings in those two climate zones. The goal of that was to be able to identify energy efficiency measures that were cost-effective and got us to this energy goal. But then to be able to create a publicly available tool, and the link is down at the bottom there. It's CBES for short, Commercial Building Energy Saver. .lbl.gov, and actually that tool is publicly available now, and that tool was actually first developed through two other previous rounds of funding, some by California Energy Commission and some by the Department of Energy, that have done previous work to develop a free access tool to evaluate retrofits throughout the US and California to lower energy savings goals, maybe about 20% retrofit. 20% energy savings. So this project really took it to the next level of, how can we get to Zini equivalent cost effectively? And then as part of the project, we also pilot tested the package as a strategy at a demonstration site. That pilot test is currently underway. We don't have results from it yet, but I can give some updates on it from where we stand. So we had some other goals with the project. One was to be at least 30% better than 2013 California Title 24, the energy code that is relevant to the state of California. We also had financial goals. We wanted to target the cost of the retrofit to be within 10% of conventional construction costs. So what I mean by that is if the building was going to be doing a similar retrofit to make sure in terms of like the systems that were touched, that the Zini measures were within 10% of those costs. We also had a goal of achieving an internal rate of return of 5% within 10 years. And you'll see from the results that in some cases we exceeded those goals. In one case we didn't, but I think you'll understand why that was in a minute. So our process was this. We started with two theoretical 50,000 square foot commercial building office buildings built in around 1980. And they're two-story buildings, and we used the California Energy End Use Survey, SUSE for short, which is a 2006 survey of energy data across the state of California at the building level to be able to calibrate those two-story buildings into a representative condition of the state of those buildings in Northern and Southern California. We also calibrated those models to utility data that was available for their market sector locally. So we used PG&E has some market data, and also Southern California Edison that we used. We also defined two standard or business as usual retrofit packages. So this was needed for us to be able to do the cost comparison study. And the reason why we picked two is because we recognized on the HVAC side, there is pretty, good range of existing systems that can occur in small commercial buildings. So we wanted to cover two typical cases, if you will. One that had a VAV rooftop unit with gas heat, and the second that had a VAV cooling unit with a hot water boiler that worked with VAV reheat boxes. So those two have pretty different cost profiles, but we wanted to be able to evaluate against those two conditions in this project. Our strategy with this project overall, we want to create a suite of energy efficiency measures that a user could select from to see if their building could get to Zini. And in order to do this, our strategy was to basically focus on 3 Zini retrofit packages first that had different areas of focus. So one was highly envelope focused, and that would be perhaps applicable to a building that was already going to open up its walls or replace windows for other reasons, and really kind of dig in on what would be needed on the envelope side. The second was more lighting and daylighting focused. That included some skylights as well. And then the third was very HVAC focused. And that's not to say that we expect all the retrofit projects to fall under one of those 3 categories, but rather what those 3 cases did for us is create sort of the strongest or most aggressive energy efficiency measure in each of those 3 categories that we expect a building to need to be able to access to get to ZNE. So what the most efficient HVAC unit might need to be in order for them to get to ZNE potentially. So the idea here is just to create a suite of energy efficiency measures that could allow a specific building to cover a range of different combinations. So I'm going to be presenting the results of these first 3 initial combinations of retrofit packages, and just recognizing again that these are not meant to be necessarily the use cases for a specific building, but they are providing us the building block to provide the measures that a building could then pick and choose from. They might choose an envelope measure from the envelope package, HVAC from the HVAC package, and so on. In order to get there, what we did was we actually did create some standard shared energy efficiency measures for some of these packages. So an example would be all the exterior lighting. So, oops, excuse me. So all 3 packages had the same exterior lighting retrofit. All 3 packages also did something in the way of plug load reduction, as listed at the bottom here, aiming to reduce 30% from the 0.77 watts per square foot to 0.54. And then the third thing that was done for all 3 packages was on the domestic hot water side. So we looked at going to electric instantaneous with low flow fixtures in all 3 cases. In a couple cases, we also had a couple of other measures that were shared. So we did do a basic LED lighting upgrade in the non-lighting packages. So that's the envelope and the HVAC focused packages to 0.8 watts per square foot. In the lighting package, we took that much more aggressively and included things like daylighting, dimming controls, and so on. And then for the first measure that's listed there on the HVAC side, for the envelope and lighting focused packages, we did have a simple sort of standard HVAC system replacement that was considered. So now on to the 3 packages. So the first one is around Zini envelope focus strategies. So in addition to those couple of measures that I mentioned just before, the plug loads, the LED lighting, and the domestic hot water, we also looked into adding floor and ceiling insulation, wall insulation, replacing the windows, doing some envelope sealing, and adding a bit of exterior shading. And I'm going to be presenting the results just of the Northern California climate. We do have all the same results for a Southern California climate, but just for sake of clarity and presentation ease, we're just going to focus on the Northern California results. So those are the measures as we needed to in order to get the building to zero net energy. And here's the EUI energy use intensity metrics for that case. So on the far left, you'll see, and we'll present this for each of the 3 different packages. On the far left, you'll see the Northern California baseline model. So this was calibrated to the SUSE data and also the utility local data. So an EUI of 65.7 initially. And then those 2 standard packages are in the middle are what the standard retrofit condition would be if they just replaced them with the code minimally compliant versions of those technologies at the same time. So those were used for our comparison on the cost side. And then on the far right, you see the results for our package. And again, this is the envelope focused package. So it is going to involve some of the most cost intensive measures. But it does end up with a pretty good EUI, and you'll see on the last slide that I present of this mix how it compares with PV production, but it did create a ZNE result just using on-site rooftop PV generation. So this package is maybe not the best one to start with in the sense that it does have the most expensive measures in it. At the bottom, you'll see that our incremental cost over the standard retrofits is significant, 30 to 40% plus, and the IRRs don't pay off. However, just remember again that this is not to say that we're recommending that this package be the way that any building gets to Z&E. Rather, we were just identifying, hey, if you know you need to replace your windows, this is a window spec that would meet the need as part of other measures to get you to Z&E. So this is just the first package. Let's look at the next one, which was focusing on lighting and daylighting as a retrofit. So here we did a little bit more aggressive interior lighting retrofit to 0.4 watts per square foot. We did include occupancy sensors and daylighting sensors and controls. And we also added some skylights into the core of the space. We focused on using tubular daylighting devices for the most part, and that just allowed better daylighting in general. So this, in combination with those three common measures I mentioned earlier, that being the plug load reduction, the domestic hot water change to electric instantaneous, and that standard efficiency, higher efficiency HVAC unit replacement, resulted in the following result. So again, on the three columns on the left are the same as you saw previously, because we're still comparing to the same base case. But on the right, you'll see that the result for package 2 is notably even better performing than the envelope-based package. And here you can see we now have metrics that are actually paying off quite well at this point. We are within our 10% cost threshold over standard retrofit. So 7% and 2% increase comparing to each of those different packages. And our internal rate of return is quite good, quite high. Moving on to our last package, this is the HVAC retrofit. And here, the package that we ended up developing is to install a dedicated outside air system with an energy recovery ventilator that recovers both dry bulb temperature and humidity. It's an enthalpy wheel. We also have a VRF heat pump and added in demand control CO2 sensors in some key locations. We implemented some unoccupied room temperature setbacks and widened the zone temperature deadbands a little bit, not a lot, just 2 degrees Fahrenheit in either direction. And then we did reduce the HVAC equipment runtime, basically paying better attention to when unoccupied hours are occurring. And again, so this package in combination with the plug load reduction measure and the basic LED replacement resulted in the following condition. Again, the three columns on the left should be the same as the ones we saw previously, and the one on the far right is the result for this package, showing pretty good energy savings. And notably, this package actually was cheaper to implement than the standard retrofits by a significant margin. And so the internal rate of return was positive from the get-go. So I think there's, this is kind of starting to hone in on what are the most cost-effective measures to be able to look at to get us to Z&E quickly. So in combination, looking across the board, all of those different conditions, this is the result. Starting on the far left, we have the PG&E benchmark for their region. We also have the SUSE data and their baseline, which is slightly less than the PG&E benchmark. And then we decided to compare against Title 24 2016 instead of 2013 because that was the more recent code relevant to the project at the current time. So that's provided as a reference. And then the two standard retrofit packages are shown adjacent to it. And then all the next three columns are the results for those three packages we just looked at. So those three packages, again, gave us some of the initial, measures to look in combination. And then we did a little bit of analysis combining measures across those packages. So package 1, 2 takes a combination of some of the measures in both packages, similarly with package 2, 3, and then package 1, 2, 3. Anything that included package 1 in a really strong manner definitely still had the highest cost impact. And I think the message there is that, and it stands to reason, envelope-based measures are probably not the most cost-effective thing to start with. There are a lot of other opportunities out there. But you can see on the far right what the solar PV potential was for these buildings. And in all cases, and marginally except for package 3, we definitely hit the Zini mark. And there were assumptions made already about having how much solar could be put on the roof. I believe 80% coverage was what was used for this particular case. So overall, we have 30 to 75% EUI reduction over these different initial conditions, whether it's code or whether it's the existing building benchmarks, which is a pretty strong energy reduction. So then, using all of these developed measures, we then built this, we then implemented them into the Small Commercial Building Energy Saver tool. And it's worth mentioning again that that tool existed before this project and already had other measures in it. We now have a very full range of different efficiencies and different types of HVAC equipment, for example. But we improved it by adding in these stronger measures and also adding in some other analysis that I'll show on the next slide. The basic goal of the tool is to help identify both retrofit opportunities and some operational improvements that can help reduce energy use in a given existing building. It actually also provides some guidance on indoor environmental quality and how to maintain good quality on that end too. This is just sort of a schematic of what the Commercial Building Energy Saver looks like. It has a lot of different parts to it. Many of these were built before the current project. I just mentioned the indoor environmental quality impact at the bottom there. It also has a benchmarking capability. So we can compare the existing building to Energy Star buildings, to other benchmark data such as through Energy IQ. If you have smart meter data, it can import different smart meter or other, utility meter data and do some load shape analysis as well to say, hey, here's what we think the most compelling measures might be for your particular case. It also does this very deep retrofit analysis that we've been talking mostly about on this presentation so far. It is based on an Energy Plus engine under the hood, but it's built for people that aren't energy modelers. The small commercial community isn't one that is going to be sophisticated in this way. So the Commercial Building Energy Saver tool was actually modeled after a different tool for the residential sector called Home Energy Saver, which is also Berkeley Lab. And there, homeowners are the main audience for that who aren't necessarily experts about building technologies. So the interface was designed with that user in mind. That being said, so with as little as 6 inputs, you could get a retrofit analysis for your building just by, selecting vintage, climate zone, and some other data. But if you were really interested, you can really go deep under the hood and manipulate schedules. You can even export the Energy Plus file and use it offline for further analysis. Some of the other improvements we did to the tool as part of the current project where we added a module for on-site renewable generation estimation. And this actually uses NREL's renewable energy calculation module. It's just been imported into this tool. It also does zero net energy calculations. Depending upon which strategy you're most interested in, whether it's Zini by cost or by site energy use and so on. We added in the new measures we've been talking about. We also added in automated demand response as a technology option on some technologies. And battery storage was also included in some capabilities there as well. To complement the rest of the project, in some cases, we decided to do some validation of the performance of both the tool, the CBES tool, and one or more of the technologies that we were focused on. We wanted to do this to be able to validate, is the tool doing a good job of estimating the energy performance and other characteristics, but also in the case of technology that we selected, the tubular daylighting device, we knew that it perhaps wasn't as well represented in the simulation software as we would have liked, so we wanted some real measurement data to understand did the tool represent it well enough for daylight distribution and also representing the reduction in lighting energy use. So we mocked up and tested one of the Zini packages, as well as the multiple configurations of the tubular daylighting devices in FlexLab at Berkeley Lab, which is a integrated systems buildings technology test facility at Berkeley. It's a DOE-funded research facility. And the real benefit of it is you can do real-time side-by-side comparison. And so we can mock up an energy code minimally compliant set of technologies in one cell, and then the new case in the second cell in real time see the difference. And we actually mocked up this project in the test bed that's closest in the picture there. That's actually on a rotating platform. So we were able to validate the entire test bed rotates from a southern orientation to west, can even do north. So we basically validated the performance of these technologies under different solar orientations as well. So we did a Zini package verification, and there we looked at not just energy performance, but also thermal comfort and visual comfort, and then suites of different manufacturers, different dome and lens configurations for the tubular daylighting devices. They're mostly focused on lighting energy use and also visual comfort. This is a result from the tubular daylighting device lighting study. The image on the lower left is actually a layout of the test cell. We created a interior zone because these are really best used in a core space. So the dashed line that you see there is actually the partition walls surrounding this smaller room. In the middle, the tubular daylighting device was oriented, and then you can see these little camera icons that are high dynamic range cameras that are taking photos with fisheye lens that are then digitally processed to understand daylight glare potential. So it's one of the metrics we look at for visual comfort. We also have photometers in a matrix configuration around the entire cell, so we could then understand the daylight distribution from just the TDD. The image on the right is actually a result of one of the tests for looking at light distribution from the overhead skylight. And the scale is a little bit exaggerated here, but it's in lux. So the upper limit there is about 600 lux and the lower is about 100. And you can see, definitely right immediately below the skylight, it's quite significantly brighter than in the corners. However, the range is actually not that wide, considering the range of acceptable lux levels in a commercial office environment. So overall, it did a pretty good job about light distribution within acceptable ranges. In terms of, and the image on the lower left here is actually of the actual test setup. So you can see one of the high dynamic range cameras in the lower left. It's got a photo sensor mounted on its top. There's actually another set of cameras in the background as well. And then the rails with all the little photometers on them are in the space as well. It's a lot of wiring because it's a lot of sensors. But overhead is the skylight. The image doesn't do a great job in one sense. There actually wasn't a big glare on the wall in the back corner there. But it was noticeable if you were to stand right underneath the skylight and look up, it was significantly brighter than the space around it. Overall, there was a 55% energy use reduction in one of the test ranges, so sort of a lower sun angle winter period. And for each of the different configurations that we studied, which were different manufacturers, different lenses, different dome configurations, there was a pretty, consistent range of energy savings in the 40 to 60% range over the base case, which did not have the skylight. For visual comfort, this is a set of images from the high dynamic range camera. On the right, you can see the fisheye lens image, and then the processed version of it, creating kind of a heat map, if you will, of the daylighting performance in the lower right. The image on the lower left is a real-time chart looking at the daylight glare potential. Anything under 0.3 is considered acceptable. There's a lot of science behind that actual measurement. I can send reference papers for people's interest if they're interested. But generally speaking, it performed really well. There were no uncomfortable levels of glare measured during the entire test period, and that's across all the different manufacturers and different product types, which was quite good. Wrapping up the project, we are doing a demonstration with the City of Berkeley, and this is the site that they selected. And in some ways, it was a really good site. It's challenging in that it does have a historic facade. It does have some other historic elements on the interior. So, you know, some constraint about the kind of measures that could be used. And also the roof area, you can see in the lower right there. The clay tile roof is historic, so it could not be modified, and no photovoltaics could be put on it. But we could put photovoltaics on the other parts of the building behind it. Currently, the project is only forecast to put photovoltaics on the lower portion of the roof. So that's sort of hopefully you can see my cursor here, but this area here. But also a couple of rooftop units are going to be put there as well. So it's a relatively small building. It is daylight challenged. There's a lot of core spaces in here. It butts up against property lines on two sides. It has a pretty high EUI for this area. It had an Energy Star score of 63, so you could say it was ripe for opportunity in this regard. It's currently in construction, and we're targeting 12 months of measurement and verification, not just on the energy side, but also on thermal comfort and visual comfort. We'll be going in and setting up some of the same instrumentation we used in the Flex Lab testing to also see it on site how that worked, how those technologies worked as well. That concludes the scheduled time for my presentation here. John Brushy is on the line with me as well. So Integral Group's role here was to help do a lot of the analysis and coming up with the Zini packages. Berkeley Lab did a lot of the development on the commercial building energy saver tool and also the Flex Lab testing. And we're jointly working together on the demonstration project site, and we'll be doing the measurement and verification as well. With that, I'd love to hear if anybody has any questions or comments. Please feel free to ask. And Sharon, I don't know if you have anything to offer in that regard at this point.
There is nothing currently in the questions box, but please, if you are listening in and you have a question, go ahead and type it in now, please, for Ms. Renier. And the only other question I had was somebody asked if they would receive a recording of this. Yes, if you are currently logged in and missed the introduction. If you are currently listening, you will probably tomorrow, but certainly within the next 48 hours, receive a follow-up email containing a link to the recording and a link to your certificate of attendance. Also, just to bring to your attention, as I did post in the chat to everybody, a copy of Ms. Renier's presentation is available for you to download right now if you would like to in the handouts section of your GoToWebinar control panel. So if you can see now, Cindy, there are a few questions coming in. Can you see the questions?
I can. I'm going to start with one that's asking about the envelope measures. And the question was just to describe what the envelope improvements are. And actually, maybe I could ask a clarifying question. If the question relates to the developed Zini packages or if it relates to the demonstration site. I'm going to go ahead and show again the slide I had earlier, though, about the Zini pack. Oop, hopefully I can get back to it. Here we go. So these were the, I'll call it the strongest set of energy efficiency measures that have been put into the tool on the envelope side. And again, certainly a building wouldn't have to do these necessarily to get to Zini, but if they're already doing something like replacing their roof and have an opportunity to install some insulation, this might be a good approach. So we did cover the bases in terms of both ceiling roof insulation, some wall insulation as well. Continuous insulation, CI stands for continuous. The green girt, Z-girts, is actually there to support the new cladding and reduce thermal bridging. So the continuous insulation is actually one of the major benefits of it is that it does reduce the thermal bridging and overall improves the thermal performance of the wall quite a lot. The windows, you can see the thermal and visual solar gain coefficients listed there. The other aspect is a thermally broken frame, again, with this concept of thermal bridges being really important. That was another key attribute. Ceiling envelope leaks, and then adding exterior shading were the others. Let's see. Hopefully I answered that question. Let's see. Okay, was the wall insulation internal or external? Aha, okay, so the question, and he also asked if external, what about historic aspects to address? So in the package that you see in front of you, we did apply them on the exterior. However, in the demonstration site, because there were historic aspects, we could not do that. So they were installed on the interior. John Brushy, I don't know if you want to add any other comment to that.
No, I wouldn't have anything more to add than what you already said.
Okay. Let's see, we'll go on to another question. What would be the anticipated kilowatt hour annual savings from the solar tubes? Boy, I don't think I have that off the top of my head. Let's see, I can maybe go to the package results. That's something we should probably get back to them on. I don't think I have information right in front of me to offer on that end. I can say, you know, this is the lighting, daylighting retrofit package. If you look at the lighting aspect here, that's a pretty substantial lighting reduction over the base case. You know, I'm going to guess that's in the realm of 60-ish%. And you can see the EUIs on the left-hand side here. So this package did include the skylights on the interior of the space. Yeah, my contact info is at the end of the presentation. I'll just put that slide up again in case somebody wants to get in touch. We can look up that information. I think that might be the best way to address that question. John, feel free to chime in if you have a different.
Yeah, I'm pulling up our data from our simulation runs, but I'll see if I can get it in the next several minutes here. You should go on to the next question, and if I can find it quickly, I'll chime in. Sure
thing. The next question asked, how could we get LBNL to do this sort of exercise for Northeast US climate zone? We would love to do that. California isn't in the Northeast. They were the ones that did support and fund this research. I think the key to that is we would need to find a sponsor willing to pay for that study. The person who asked, I think, you know, we'd be very willing to talk to different funding agencies. Zini retrofits are not on every agency's radar at the moment, although they're very important to some regional energy saving goals. So I think it is a rather regional based approach that we have to kind of think about. But we'd be very happy to, if you want to get in touch and have ideas about who would be willing to fund this kind of work, we'd be very happy to discuss that. The next question, so has your team looked into plug load management in a real way to reduce vampire loads, or has it been unnecessary? John, I'll probably rope you in on this one a little bit. I'll say a couple things about the state of California and plug loads. So Title 24 has evolved, the energy code in California has evolved to the point where there is a requirement now for new construction and retrofit. Once you hit a certain threshold of retrofit, that controlled outlets are required. You know, the details of that operation are, you know, a little bit something I'd probably ask John to weigh in on. But we did in general look at a 30% plug load reduction as part of these packages. And the strategies to get there are going to be a combination of thoughtful equipment purchase and usage, and some of these controlled outlets. John, do you want to say anything more on that?
Yeah, I was just going to say that we've done a number of plug load plug load studies, and yeah, the first is to specify more efficient appliances and office equipment. But I would generally categorize the control so far that we've been involved with as just smart power strips that are tied to some kind of scheduling or even occupancy sensors.
Great. Let me move on to the next question. You mentioned that you assume that customers were replacing windows or opening walls already. Doesn't that ignore a substantial cost associated with implementing those measures? Let me clarify that. So what I meant was our tool isn't recommending that electively you need to do that in order to get to Zini. However, we want to, take advantage of that as an opportunity if it's already there for other reasons. So let's say you had a water or moisture problem, and you're going to have to open up a wall in order to remove, damaged, drywall, etc. In that case, we offer a measure that can be used to help improve the performance of that wall. Or if they know that their windows are starting to fail in various ways, then we offer a measure that would be good to consider to try to get to ZNE. So again, we're not necessarily saying electively you need to approach those things, although certainly they are very advantageous to the overall energy picture of the building in general. Let me move on to the next one. Can you detail a little more the specifics for the package A and package B measures and why such a difference in performance? I think what they're referring to there are the two standard retrofit packages. So we actually will have a very detailed report coming out that will get very into the specifics on those, but I mentioned at the top that sort of the key differentiator for those two, package A and package B, is the standard retrofit cases. Package A was a VAV rooftop unit with gas heat, and package B was a VAV DX unit, cooling only unit, that was coupled with a hot water boiler that then worked with VAV reheat boxes. So those were considered to be, and for us, a small commercial building is 50,000 square feet and smaller. So you will see a pretty wide range of HVAC systems in those kinds of building applications. Those seem like two fairly typical representative cases. So the retrofit cost there would be, end of life equipment replacement for those types of units. So, recognizing that not only are these energy efficiency measures important to consider, but the timing of when to implement them and capturing the best return on investment is probably another part of the equation that's important for small businesses. Let's see, I think I may have addressed that. Let's move on to the next question. Why didn't you create a package or packages that combine the solar renewable option plus the other packages and model the resulting EUIs? We did model all the package. So again, one of the goals is to create a suite of measures that can then be put into this analysis tool. And that analysis tool has a lot of measures and it has renewables. So it provides the information to the user to be able to say what combination of those strategies is useful for them to get to ZNE. Perhaps I don't quite understand the question, but I think we did create the potential for somebody to look at packages that combined different measures and renewables options to get to the ZNE condition. Hopefully I addressed that, but let's move on. Let's see. I'm assuming from this discussion that the modeling here is not necessarily IPMVP compliant, and that is because this is on small facilities and not necessarily part of an ESPC. I wouldn't say that. So IPMVP, is for the measurement and verification end of things, and certainly, that is a good strategy for measurement and verification. I wouldn't necessarily say that we are dictating to a small business owner, what strategy they want to use for measurement and verification. That's sort of outside the bounds of this particular research project. We were mostly focused on providing, owners and implementers with a cost-evaluative information around energy efficiency measures. And we certainly are big proponents of measurement and verification as part of a ZNE program or a ZNE retrofit. But we are, as part of this project, we weren't looking at delivery methods like ESPCs but we were mostly just concerned with providing the energy efficiency measure information to these decision-making parties, and then they can go from there and decide how they would like to implement them, what party, and so on. And frankly, the tool can be used by ESCOs, it can be used by consulting engineers, contractors. It's not limited to the small businesses or small commercial building owners that we've been talking about. So it could be a good resource for them as well. Got some good questions here. Let's see. What are the general objectives for these tools? Expected uptake and rollout of use. So the general objective, we stated at the very beginning of the presentation, was to be able to empower the small commercial building market with the same kind of evaluative information that larger commercial buildings can get by hiring consulting engineers and being able to do energy simulation. You know, it's just not cost effective for small commercial buildings to be able to do this kind of work. You know, for the amount of kilowatt hour savings on a per square foot basis, you're not going to save enough energy to justify hiring and doing a full audit and whole building simulation. So we're trying to replace that and offer that to this community who's underserved. In general, the CBES tool has been used, I'm not going to be quite sure how long, I'm going to say 5 to 7 years now. And it's had about 30,000 different users. It's been used in the context of doing retrofits. It's also been used as a training resource for community colleges and for engineering students to try and better understand, retrofit opportunities in general. Okay, let's move on to the next one. In considering rooftop PV at 80% coverage and achieving Zini, do you think consideration of roof age and potential upgrades drives the envelope package to a more acceptable IRR? Interesting question. Well, in general, I do think, as part of the decision-making process for any retrofit, you do need to kind of think holistically about the life cycle of and the life cycle costs around different technologies or envelope components. It could be that we might get to a better IRR if there's a different combination of measures looked at. And I do want to say, I'll repeat it, I don't think we're necessarily saying you need to go out and do all these very strong envelope measures that are cost intensive. It will be the case that maybe a small subset or none of those measures make sense for a given condition, but other combinations of measures from the plug load side, the hot water side, the HVAC side could in combination come together to get to ZNE. So I think the point is that we were trying to offer a suite of measures that could be options for people. And my expectation is that the IRR would get better and does get better when you de-emphasize envelope measures and focus more on these other end uses. Let's see. How likely is ZNE with buildings that have packaged rooftop units for HVAC and screen wall? Well, the demonstration site that we're looking at in the city of Berkeley is that exact case. It is putting 2 rooftop units with screen walls around them for acoustic purposes on a roof, and the remaining available roof area is getting, on the lower portion of the roof, is getting photovoltaics. And right now, the estimates are that it will pencil out at zero net energy. And with an additional high roof area that could have PV put on it in future if they want to install something like an electric vehicle charger. So I'd say it's realistic. I think for our particular case, 50,000 square foot buildings, 2 stories and less, I'd say that's quite achievable. It certainly gets a lot harder, as you're probably aware, with buildings that are more stories high. Let's see, regarding using occupancy sensors and daylight harvesting with LED lighting, due to being in the Northeast and lower electric rates in California, I've not seen either being cost effective. But what percentage kilowatt hour reduction do you expect? I would actually refer to other projects for an answer on that front. And I will agree that with LED lamps becoming very cost effective and providing the bulk of the energy savings, lighting controls has diminishing returns, and the ROI can be, it might be more strategic to just focus on lamp replacements and maybe something simple like occupancy sensors rather than daylight dimming, which can be more cost intensive. There is other work done by Lawrence Berkeley National Lab that actually has looked at in more detail the question of the incremental value of these lighting controls. If you go on to lbl.gov and the commercial buildings webpage, which I should know, but it's not rolling off my tongue right now. Oh, actually, buildings.lbl.gov. You should go there, and then if you look for a program called Beyond Widgets, we'll have research there that's relevant to that question that shows studies that have compared not just the kilowatt hour difference, but also the simple payback is the metric I think that was used there. Or you can search for my name. I helped to author one of the papers related to that. It's compared component like lamp-based replacement to lighting, 3 different systems which all included lighting in different configurations: workstation-specific lighting, task ambient lighting, and a third one that's not occurring to me at the moment. So yeah, I think I would refer you to that. Let's see, I think that's it for questions. Thank you guys, those are really excellent questions. I really appreciate your time. And John, do you have any last comments or you want to throw out to the crowd?
No, but other than I think you did a wonderful job in presenting and addressing all those great questions.
Sweet. Well, thank you, everybody. Really appreciate your attention and interest in this topic. And by all means, please visit the website. We will be posting our paper there, along with the results of the demonstration site study. So thank you again.
Okay, thank you, Ms. Renier. That's a great presentation, lots of good questions. So thank you everybody for listening in. Just to finish up, I just want to bring your attention to a couple of quick things. Obviously, many of you are aware, if you're not, we have our AEE World Energy Conference and Expo taking place in DC next month, and we would love to see as many of you there as possible. So please come out and join us. And then our next AEE member webinar will take place on Tuesday, 17th of September. And that is about sub-metering with Gord Eklund from Triactor Power Solutions. So it's not enough to measure, sub-metering best practices. We hope you guys will join us for that one too. That will be posted on our website in the next few days, and you'll be receiving an email from us letting you know about that one and then the following one too. So thanks everyone for tuning in today. A huge thank you to you, Ms. Renier, for your time today. We certainly appreciate your time and expertise, and to Mr. John Brucey for being online with us also. So thank you guys. Thank you to everyone. We look forward to seeing you again soon.
Thank you,
You're
Sharon.
welcome. My pleasure.